my screen and we'll get started.
Mhm.
Share screen. All right, so it says find the location of the maximum absolute extreme for the function. They're basically just looking for the highest value, and they just want to know where it is. So the highest value is here at 0, 0, 4, and they're just asking where it is. So that's x equals 0. Nothing more to do on that, pretty much. So let me grab the next question. Just a moment here. There it is. Okay. All right. Okay, so it says to find the absolute extremum as well as all the values of x where it occurs on the specified domain. So they're not specifying here whether it's a min or a max. So what I'm going to do is I'm going to graph it, and I'm going to restrict the window to -1 to 2.
Mhm.
And I'll snip that graph in here so that you can see, and then we'll be able to identify it with that information there. All right, so let me snip this in. All right, so here is what the graph looks like. You can see that I'm sorry, they do want the maximum extreme. So you can say the max is down here at this point, which is 2, 0. So they're giving you both answers when they're asking you, they're giving you the answer where it is. It's at x equals 2, and then what it is, which is 0. And that's just from the graph there, nothing more. You could take a derivative, but you can also just graph it. So why not just graph it?
All right, got that one.
All right, same thing for number 3 here. Let me snip that in. I'm going to graph it because I really want a visual picture of it to confirm what I already know about the calculus, which is the extreme that occur either at the endpoints or where the derivative is equal to 0. So just give me a moment here to pull up the graph of this. This one's the extreme window, there's no windowing of it. It's just everything. So we'll look at the entire graph this time. So minus 3x to the 4th plus 20x cubed minus 36x squared plus 9. And let me get the graph. Oh, 3x to the 4th. That's important. Get the wrong exponent here. Plus 20. All right, so I'm just getting the graph in here. Just change the window a little bit here. Minus 3 to 3. Yeah, that's a nice window. Be able to see everything in that. They really do owe it to students, in my opinion, to give them a little bit better, explanation, or here's how we graph stuff so that you can answer some of these questions with the graph. So this is the graph of this function here, and we want the absolute extremis. It occurs right there. That's the max. And the point there, I know I don't have it at 0, 9. And so it's like, where does it occur? It's at x equals 0. And then what is it? It's 9. And there's no minima because the graph goes down forever and down forever. So
Okay.
even though you might think, well, isn't it at minus infinity? It's like, well, yeah, it is, but it doesn't, because it's like a destination that you can never get to. We never consider it in math. In real life, you do have an infinity. I mean, maybe it's a 5-year horizon or a 10-year horizon,
Right.
All right. So let me get back to next one here. All right, here we go. All right, so here's the next question. So they give you the profit function right here, and they tell you that it's for x greater than 3. So I'm going to graph this again, but I'm only going to graph for x greater than 3, and we're looking for the place where it's a maximum. So wherever the graph, it hits the highest point here.
Mm-hmm.
All right, so just a little different window this time. Let's go 0 to 15. All right, we got it. All right. All right, so I'm gonna snip this graph in so you can see it. I mean, whenever you go to a presentation in the workplace, like everyone's like, I want to see what it looks like. And like, that's why this graphing is so important because, you want to know what does the graph actually look like. And right here, this is the peak, 8,514. So because X is in 100,000 tires, their answer is 800,000, like that.
Okay. Okay.
All right, so 5, here's the first question where we've got to do a little work on our own before we can just either graph it or determine the answer. So it says the price charged for a candy bar, P of X cents, then X thousand candy bars will be sold in a certain city, where 141 minus X over 34 is the price. So revenue is price times quantity. So your price is 141 minus X over 34, and your quantity is X. Okay, now there's a bit of an issue for me here because they don't the revenue is not in dollars, the price is in cents. So I would probably multiply this by 100. It doesn't actually affect where the maximum occurs. It just gives you your answer in dollars. We don't need that in this problem, but I always find it complicated when graphs don't give you the units that are kind of what we want them to be.
Mm-hmm.
That you don't go, we think of money in terms of dollars, I guess, not cents. At least that's my opinion. So
Mm-hmm.
I'm going to go to the graph again and get a snip of this so that we can see what it looks like. And hopefully it's something that's reasonable, which I think it will be. And let's see here. So I got to change my window to, let's see, the biggest number in that list is about 5,000. And then on the Y, I see. Now I know why they gave it to you, because the number gets huge, really big. Okay. All right, so here we go. So here's the graph of it. You can't see it, but on the on the y-axis there, I mean, we're up to like two. It's 2 times. I guess you can't see it. 2 times 10 to the 7. So, but you actually only care about the x value because it just wants to know where it occurs. Now, the answer. Ooh, gotta be careful. So it's candy bars and 1,000 candy bars.
Yeah.
But X is in 1,000 candy bars. So it literally is 2,397,000 candy bars.
Okay.
And one of the problems, one of the problems with this, we don't have any context. Like we don't know if this is just, Billy making candy or some mom and pop shop, or if it's, whoever makes, like Reese's, they're making, millions of candy bars right now. All right, moving on to number 6. All right, a rectangular field is to be enclosed on 4 sides with a fence. Fencing costs $2 per foot for 2 opposite sides, and $8 per foot on the other 2 sides. Find the dimensions of the field of area 690 feet squared. That would be the cheapest to enclose. So I'm gonna use standard measurements X and Y, and the area is X times Y, but the area is given, it's 690. So that's 690 equals X times Y. The thing we're trying to minimize is the cost. Okay, so the cost is, and this is where I think it's maybe unclear as a student, what do I do next? but you just arbitrarily choose like, okay, I'm going to make 2 go along with the X. Because there's X, X, and Y, and then I'll do the 8 with the Y. Now, if you're really curious, you could do it both ways and see if it changed the answer, and you would find that it does not. But it's I think it's a little bit unclear. So sorry, I'm trying to get this framed right. Oh, do that good. So our problem here is that the cost function has both X and Y in it. And that's why this other equation is so valuable, because you can solve it for Y, for example. And you can substitute that in for Y, and then your cost equation is only defined in terms of X, which is what you want. So the cost function right here is a graph. We can graph this and then see where it is minimized because it says cheapest right there. So the idea is you draw a picture, you write the 2 equations, and then you write the you substitute into the other, and then you graph it to see what it looks like. All right, and then let's see if I can get a reasonable window. Okay, so I'm not getting it. All right. All right, so here's what the graph looks like of the cost function. And the cost function, this X right here is our X. 52.536 is our X that we've been talking about here. Boy, this doesn't look right. No, I guess it does. Sorry, I didn't see that that's 52.5. And that's what this is, 52. So your X is 52.5. To find Y, you go back and use this other equation. So the 690 divided by the 52.5, and that gives you the 13.1.
Okay.
And that gives you the 2 dimensions that you're looking for here.
Okay.
And like I said, if you had flipped it, you would have just gotten the flip of this answer, or you still get this answer. You just would have found that X was 13.1 to go with the $8 side. You just gotta be very careful. So the X goes with the $2 and the Y goes with the $8. And I'm sure this is multiple choice for that reason. That way there's no gripes about grade and things like that. Because but anyway. These optimization problems are kind of interesting because we do try to optimize these things in real life. They're just never this simple.
Mhm.
All right, so it says here, bookstore has an annual demand for 29,000 copies of a best-selling book. It costs 40 cents to store 1 copy for 1 year, and it costs $70 to place an order. Find the optimum number of copies per order. So this has a formula that I don't recall, but it's based on like demand and shipping cost and order cost. I just need to look up that formula. So give me a moment here to find it. We did a problem like this earlier, and I just couldn't tell you what it is. Okay, so the formula here, the EOQ, economic order quantity, is the square root of 2 times demand times the order, I'm using the wrong letters here, but it's the order cost over the storing cost or shipping cost, stored cost. But the result here is that it's 2 times 29,000. The order cost is $70 over 0.4, like that. And
Okay.
this you'll see again if you take any supply chain management classes. So this is 3,186.
Okay.
And I guess the idea is like that's the right number to order so that you can just run out and reorder and be okay. All right. Okay, so new question here. Find the elasticity of demand. So the elasticity of demand is minus P over Q times dQ dP. So in this problem, you have part of it already. You have P is your variable, Q is the 43,000 minus 10P squared. And you just need to take the derivative of this with respect to P. So it's just the power rule. The derivative of 43,000 is 0. And then the derivative of this over here, you bring the 2 down, multiply by the minus 10, so it's minus 20P. And so you're multiplying by minus 20P like that. And you look at your answers and you're like, none of my answers seem like they're there. Well, it is, but on the bottom, they have factored out a 10 from both. So the bottom becomes 10, 4,300 minus P squared. And then that 10 cancels with this 10 up here. So that's minus 2P. So you have minus P times minus 2P, which gives you 2P squared on top over the 4,300 minus P squared. Like that.
Okay.
I almost circled the wrong one. Easy to do. Easy to do. Okay. Any questions on that?
Mm-mm.
Moving right along here. Okay, so solve by implicit differentiation. So the key here is to remember that when you take a derivative of y, the derivative of y is y prime or dy dx. It's not just one, but you start with the 3x squared for the first term, and then the second one's really product rule. So it's the derivative of the first times the second plus keep the first derivative of the second, which is your dy dx, and then the y cubed is 3y squared, but dy dx equals 0. Derivative of beta 0. So you organize terms. Just gonna run through the algebra here pretty quickly. And then this equals minus 3x squared minus 6xy. So just moved the 3x squared and the 6y to the other side, and then you get this here, and then you divide everything by the 3x squared plus 3y squared. And you look and you're like, oh, none of my answers are there because there's a 3 on the bottom. So the numerator and the denominator both have a 3 that can factor out of them. So in the numerator, it's minus x squared minus 2xy. The denominator becomes x squared plus y squared. And that will do it. So it's like, well, which one's my answer? Well, I actually factor out a negative out of the numerator.
Mm-hmm.
So it becomes x squared plus 2xy over x squared plus y squared. So this is a great example of a problem for like a lot of students, like, oh, give me multiple choice, but this one's kind of, the answers are deceptive with, what is the right one? Because you have the answer here, you even have it here, but it's
Mm-hmm.
packaged a little differently when it comes time to actually submitting it here.
Yeah.
All right, so I'm gonna do this next problem a little bit differently. I'm gonna graph the equation right here, and then I'm gonna graph the 4 lines, and we're gonna see which one is actually tangent at that point. Which I think is kind of a neat visual just to see that it actually works the way it's supposed to when you graph these things. So I'll snip in the picture after I'm all done here with 2y equals 0. All right, and then we're going to graph y equals minus x equals 0, y equals minus 2, and y equals minus x minus 2. And we want the one that goes through, that's tangent at that point right there. All right, let me snip this in. All right, so here's what I did just for clarity. So I graphed the green as the original one,
Mm-hmm.
and then I graphed them in order here of these, which I know you can't tell, but we want the one that's tangent at 0 minus 2, which is this point here. So the one that's tangent is this horizontal line, which is y equals minus 2, and that's your answer. Now we could get it doing it other ways, but tangent to a circle means it oops, it only hits one place, like that. We could use the calculus, but we don't need to. All right, did I miss one?
No, that should be 10. We should be on 11, which is a separate email.
All right, so yeah, there it is. Okay, so this next one I'm going to do the same way because it's much faster than trying to take a derivative and set it equal to 0 and blah blah blah. It's just so because it's kind of the same. So you graph the equation and you look for the one that hits it at 1, or 1 is tangent to it, and that that's why calculus is so useful. It's so important to know the graphs to be able to do this. So let's see here. Y equals 1/2 x plus 1/2, and that is not it. All right, so here it is. All right, so this is the second equation. You can see that it's tangent there at 1, 1. Just hits it, bumps up against it real nicely. Do any of these look familiar to what we've been doing the past, I don't know, I guess it's been almost 9 weeks.
Yes.
Or 12 weeks. Oh, good. Good. It should be somewhat familiar. All right. This one says find dq dp, and that means you want to think of this as a student as dy dx. My screen just froze up for a second. Come on. All right, dy dx. So I actually, as a student, what I would tell you to do is actually replace the letters. So this is 6x squared plus y squared equals 1100, like that. Q is really y, p is really x, and then you just take your derivative the way you normally do, 2y dy dx, which is really dq dp, and then you solve it for dy dx. So dy dx equals minus 12x over 2y, which is minus 6x over y. And like I mentioned, y is really p, so the p is on the bottom, and the q is really, I'm sorry, that's not right. That will mess us up here. X is really p, so minus 6p, and then q is really y, so that's it right there. Because you see that the flip of both answers is there. That's why I get really careful with this. I really hope the questions get faster. These are taking too long. All right, let's keep going here. Company knows that the unit cost and revenue is given by this function. Find the rate of change of revenue per unit when cost per unit is changing at $14 and the revenue is 4,000. All right, so you're trying to find DC, dr. So the derivative is 2r over 148,000 times dr dr prime. We'll just leave it like that. And they give you the revenue. The revenue is 4,000. This number stays, and then you're multiplying by 14. That's this number here, this number here. This is called a related rate. But I would understand if this all feels jumbled at this point, but that didn't work. Find the rate of change of revenue per unit when cost per unit is changing at $14 and the revenue is, did I not multiply? Find the rate of change of revenue per unit. Oh, I see. Why did they do it this way? Okay, like what I'm noticing is that they want the rate of change of revenue
Mhm.
per unit, and they want this is not right. Okay, they want something different than I did here. They want this number here, this dr prime here,
Mhm.
and they're telling you that the dcdr is 14. So it's 14 equals 2 times 4,000 over 148,000 times this dr that we want. So we're just going to divide this onto both sides, this thing in parentheses here. So
Okay.
it's 2 times 4,000 over 148,000. We have not seen a question like this. This is different than the ones
Yeah.
we've been doing. All right, so let me I really hope this works out. 4,000 divided by 148,000. Yeah, it ends up being 259.
Wow.
So they do this in business school. They do flip like CNR and Q&P. They always are the more difficult questions. So you just gotta look out for those. All right, 14. All right, product sells by word of mouth. They give you a function here, and they want to know how fast the rate of sales change when 800 units have been sold, and they tell you it's $100 per month. So you have to find R prime of t. So R prime of t ends up being 4 over 2 square root of x times what's called x prime, and that's 2 over square root of x times x prime, 2 over the square root of 800, and then your x prime is 100. And we're just substituting those numbers in here. And let's see here, 2 divided by that, square root of 800 times 100. So 7.07, which is not an answer. I mean, it's there, but it's not in the right units. X is the number of units produced sold, $100 per month. Do you see anything here? This is like thousands of units.
Hmm.
The revenue. Oh,
Round
how
to the
fast the
nearest
rate of,
dollar per month.
oh, this is what this is exactly like the previous problem. I put the 100 in the wrong place.
Oh,
So
okay.
it's unfortunately it's 100 equals 2 over the square root of 800 times this x prime, and that's what we're solving for instead.
Okay.
I had to read the problem a little more closely, and that's 1414 a month.
Okay.
We did not see any problems like this. So you could email your instructor and complain if you thought it was unfair. Okay, back to some faster problems here. All right, so this is really integral x to the 1/3 plus x to the, 1/2 plus 1/3 dx. So the antiderivative is you add 1 to the exponent, 3 halves, and you put the new exponent, you flip it and put it out in front. So that's enough to tell you the answer is letter B. We'll just continue on from here. So it's 4/3 over 4/3, which becomes 3/4 plus C. So you can usually get it with like one of the antiderivatives.
Okay.
Like that.
Yep.
Okay. Here we go. All right, so this time power rule again. So you add 1 to the exponent, you divide by the new exponent. So that gets rid of letter C. The E one's a little bit harder. It is itself, but you have to actually divide by the new power in front of it. So that gets rid of those two for that. And the other thing is you could take a derivative and see if you get back to the original if you need. But this is one that we've seen a couple of times here. All right, find the integral. So that the rewriting this would be slightly helpful here. It's 1/6 times x plus 6 times 1 over x dx. So the first one is power rule. It's 1/6 x squared over 2, which gets you to 1/12 x squared. And that basically gets you down to answer C. But the next one, 1 over x, is the natural log opposite value of x, and that 6 just comes with it. But it's that first one that really helps you to differentiate between the answers.
Mm-hmm.
All right, next question here. All right. All right, the rate at which an assembly line worker's efficiency changes with respect to time is given by this function here. So you have to find the antiderivative of that, and it's power rule again. It's 55t minus 8t squared. So you add an exponent to that over 2 plus c, and then you use this initial condition to find the answer. But it gets rid of one of the answers because it's 4t squared plus
Right.
c. So the idea for the next part is that 96 equals 55 times 1 minus 4 times 1 squared plus c. So you get 55 minus 4, which is 51. You subtract that from both sides, and you get c equals 45 for your constant.
Okay.
Suppose that the acceleration of an object is given by a of t, and the initial velocity is given, and the position is given. Wow. Okay, a lot going on here. This is like way harder than the previous ones. So you have to integrate this thing twice. The first time you integrate it, you get t to the 5/3 because you're adding 1 to the 2/3. You divide by 5/3, which is the same as multiplying by the reciprocal, like that. So that ends up being just 3t to the 5/3. The e to the minus t becomes e to the minus t, but you have to deal with this negative. It comes out in front like that, plus c. This doesn't eliminate any answers because we have to find that constant of integration. So this is your v of t. So you're using this. The velocity of 0 is 8. So that's 8 equals 3 times 0 to the 5/3 minus 2 times e to the minus 0 plus c. So the first one is 0. E to the 0 is 1, so this becomes minus 2 plus c. That gives you 8 equals that. So c is 10.
Okay.
Right. And that actually it eliminates these two answers. I'll show you here as we carry on the calculation, but it kind of eliminates one more, but let me just carry this on one more step here. So you have to then integrate this. So it's t to the 8/3. And then 3 comes down, but you multiply by 3/8 minus, I'm sorry, this will be plus 2 e to the minus t, because the minus again has to come out to cancel with that one, plus 10t plus c. So if you look at the two options that remain, it really it's got to be that one for a number of reasons. Mainly the coefficient here is 9/8. This is 10t instead of 10.
Mhm.
But then you would find the constant of 5 if you kept going.
Okay.
But I don't think we need to go any further on that. All right, so number 20 here. So we got we're moving through the integration. This is now the integration with u substitutions. So your answer has to have, well, I guess we don't do this. Your answer generally like wouldn't contain this 1 minus 6x because it pops out from after you take the derivative.
Mhm.
But the way we had been doing this before was we let u equal the exponent. And then we found du, which was 3 minus 18x dx. And then if you factor this, it becomes 1 minus 6x dx. That's somewhat useful for the back substituting. So it's 1 minus 6x e to the u, and instead of dx, you put in du over 3 times 1 minus 6x. Those cancel, and your integral is 1/3 e to the u du. And then your antiderivative is e to the u plus c, and your u is the 3x minus 9x squared plus c. So you can see it's letter A.
Okay.
And all right, so let me look ahead here just a bit to just kind of gauge how we're going to do here on this.
Sure.
We have plenty of time, but I just want to make sure I've got all the questions too. So I got this last one came in with everything. All right, there's 21, 22, 23, 24. All right, so we're on 21, is that right?
21, yeah.
Okay,
Mhm.
fantastic. All right, so let's find the integral that's given here. One of the things that like you might notice is the derivative of x to the 6 minus 2x to the 5th. The derivative of this is 6x to the 5th minus 10x to the 4th, which is this right here.
Mhm.
And that really helps you to determine the answer here. So I'm going to do this one backwards. I'm going to tell you the answer. We're going to take the derivative and see that it is this thing up here. So that it's 1/6, then you take the 6, it's the exponent, bring it out in front. And then take that exponent down by 1 to a 5. So notice 1/6 times 6 is 1, x to the 6 minus 2x to the 5th power is here, but then you have to multiply by the derivative of the inside function, which is 6x to the 5th minus 10x to the 4th. And the derivative of c is 0.
Right.
So when like if you were given more of these, you could do it with that approach where you just take derivatives of the one that kind of looks correct here.
Mhm.
All right, find the integral. So again, like if we look at the bottom here, the derivative of the bottom is 5t to the 4th plus 15. And if you factor out of 5, you get t to the 4th plus 3, which is in the numerator. And that really helps you to dial in your like your answers here. So again, we'll just do it this way where this is the answer, and let's take the derivative of this. So it's 1/5 times the derivative of natural log is 1 over whatever's inside, but then you multiply by the derivative of the inside, which is 5t to the fourth plus 15. And we already said that 5t to the fourth plus 15 is really this 5t cubed. So that 1/5 here cancels with it. And what's left over, t to the fourth plus 3 over t to the fifth plus 15t minus 4 is that original integral there.
Okay.
All right, so this one, we'll do the traditional way with the u substitution. The natural log of x, and then du is 1 over x dx. You solve for dx, so dx is x times du. And then you go back and you substitute in for what you know, leaving what you don't know. And what you really hope for is that there's a cancellation. So in this case, the cancellation gets rid of the x's, which is the idea of the u substitution, and you're integrating u to the fourth. So our answer is going to be 1/5 u to the fifth. So that really gets rid of a bunch of answers here. Because got to have the 1/5. Kind of also gets rid of d because of that. There's no x in the bottom. But if you substitute back in your u, you confirm that it gets C. All right, so next question here. All right, approximate the area under the graph of 3x squared minus 2 from 1 to 5 using n equals 4 for right endpoints. So the graph of this thing looks something like this. And since we're using right endpoints, you go wherever the right side of the graph is, that makes a rectangle here. And then you hit it again and you get another rectangle, and you hit it again, and so on. And so you end up getting 4 rectangles here total. So to do this, you need this calculation. You need b minus a over n. That gives you the width of the rectangle. That's 5 minus 1 over 4, which is 1. So that's how I knew to start this thing at 5, 4, 3, and then 2 for that.
Mm-hmm.
Is that right? Yeah. And actually this thing crosses. The graph's not quite accurate. It doesn't cross. The one, this 2 should be on the other side, but
Okay.
nevertheless. So your formula here is you take your delta x and you multiply by f of 2 plus f of 3 plus f of 4 plus f of 5. These are the heights of the rectangle. And you get those numbers by plugging in 2, 3, 4, and 5 into this function here. And just to avoid any calculation errors, I'm going to go to a calculator here that'll do the right endpoints for us.
Mm-hmm.
But that is the idea. 3x squared minus 2 from 1 to 5, and we want 4 rectangles, and calculate here. So the answer is 154.
Okay.
All right, let's keep going here. Okay, so this one also uses a calculator for right endpoints. So I'm just gonna go right to it after I submit or snip the question. And again, there's many of these out there. You don't have to. They all work sort of the same. So this one uses right endpoints. There is a difference between right endpoint, left endpoint, and midpoint. It's kind of it's a deeper topic in calculus and numerical analysis to know like which one to use and why, and which one has the smallest error. And it depends on the shape of the graph, whether it's increasing or decreasing, or whether it's concave down or concave up. So that all these things play into which one you would use. But this one is letter A
Okay.
for that. All right. I'm going to keep going unless you want us to stop for a short break.
I am good if you're good.
Yeah. All right, so it says find the exact value of the integral using formula from geometry. That we don't need to do that. We're going to find the antiderivative and we're going to evaluate at the two endpoints. So whenever you have a polynomial, when you evaluate at 0, it's always 0. So this is 3 times 3 minus 1/2 3 squared. So it's 9 minus 4.5, which is 4.5. So just using the power rule, antiderivative, plug in your endpoints, and you get the answer.
Mhm.
Now your calculator, like your regular TI-83, can also do this. So for the next couple, I'm going to start just going right to a calculator
Sure.
to get the answer here for us. And this is encouraged. It's not like this is a shortcut. It's just at some point you're like, all right, I got the idea. I don't need to do this over and over again
Mhm.
with the calculation. So integral 2x squared plus x plus 4 from 0 to 5. 2x squared plus x was from 4, not 5. Let's change the answer. So this becomes 695 over 6.
Okay.
So this one, the answers aren't numerical in the sense that they're not friendly numbers, but you can still use the approach that I've talked about, where you can just plug this into a calculator, and you
Mhm.
could actually evaluate each one to compare it to. And we have this option because the answers are multiple choice.
Mhm.
If we didn't have this option, we would have to do it by hand and try to figure it out, what to put into the calculator and what to write and all that. So I'm just going right to the calculator. This one I'm using does give it to me symbolically, but it doesn't have, we don't have to have that requirement here. And in fact, if you were to take calculus 2, you would find out that most of your answers you end up having to approximate anyway. There's very few integrals that you can actually do by hand. So if you simplify this, it's 2 squared of 19 minus 8, or letter C. But like I was mentioning, this is 0.7178, and you could just compare each of the answers there.
Mhm.
So if I were given the test, I would make multiple answers add up to this to avoid that where the student could just check it and make them figure out the correct symbolic answer.
Okay.
But
Yeah.
like, you're never going to do this in real life. I mean, nobody's going to ask you to integrate. Nobody ever asks me to integrate. It's just, it just doesn't happen. So even outside of just these classes. Okay, number 29 here. Moving right along. All right, so use the definite integral to find the area between the x-axis and f of x over the indicated integral. So this is the integral from 1 to 3 over x cubed dx. So you could again go to your calculator and just do this, or you could use the power rule of the integral, but you do have to evaluate both endpoints this time. But this one does work out nicely. You can see all the answers are there. They're not strange or anything like that. So if we got integral 3 over x cubed from 1 to 3. So that's 4/3. All right, number 30. All right, so let's just find the area of the shaded region. We see that the shaded region goes from 0.5 to 2. And then we have the function, it's 1 over x. And the answers are all they're all there. They're all ln's. They're all natural logarithms. So
Mhm.
the antiderivative, this is natural log of x evaluated from 0.5 to 2. So you're like, all right, well, natural log of 2 minus natural log of 0.5, which is really 1/2. So it's like, well, what's my answer? So the thing here is that there's a property of logarithms where this becomes natural log of 1. I guess that's not going to appear again. Natural log of 1 minus natural log. Sorry, I'm having a little technology issue here again.
You're fine.
Why is it doing that? So natural log of 2 minus the natural log of 1/2. This becomes the natural log of 1 minus the natural log of 2. But when you negate it, then the second one becomes positive. And so you actually have 2 natural logs of 2 minus the natural log of 1. This one's really 0. It's a property. And then this 2 comes up here. So it becomes natural log of 2 squared, which is the natural log of 4. And so like this is one of those where your calculator might not actually give you what you want. That's letter C, by the way.
Mhm.
And you just have to manipulate it to look like the answer.
Okay.
Just looking ahead here again. Okay.
Mhm.
All right. I'd like to just take 2 or 3 minutes for myself here and then
Yeah,
jump right back on. I'm just going to mute. We don't have to leave, but let's just start right back at on the hour there, 3 o'clock. I'll be right
sure.
back though.
No problem.
All right, I'm back. Let me know when you're ready, and we'll get going here.
Ready, Freddy.
Excellent. Okay, so I almost went to number 11, and now I realized I was like, why did we go back? So the breaks are good for me as much as they are for the student here. So next question here continues where we've been doing. It gives you a velocity function and it wants to know how far it went in the first 4 seconds. So the answer here is to integrate this function here. So I'm just going to write to a calculator and determine the result here. So we're integrating x squared plus 6x plus 4 from 0 to 4. And that's ends up being 85.3 meters. So not too bad. 32. All right, 32 says find the area between the curves here. So I'm going to quickly graph this so that we can see where the two curves intersect. All the previous problems gave us some indication of where that occurs. Now you can do it algebraically by just setting the equations equal to each other. But of course, if you've got the ability to graph it, really helps to show those spots here. So let me grab that here. All right, so here is the graph. All right, so the graph shows us that we want the area between the two curves, that there's an upper area and a lower area. When you're integrating, it's top minus bottom.
Okay.
So the way that you work around that is you do the absolute value of it, and then you don't have to consider that. But you're essentially integrating from -2 to 0, but your top is the x cubed and your bottom is the 4x. And then you can add to it 0 to 2, the top, which is 4x minus x cubed dx, like that. Or you can do the absolute value. So the answer here is, let me get a calculator going. Let's see here, absolute value. -2 to 2. And ends up being 8. So each of these individual areas is 4, and the total is 8.
Okay.
So integration by parts is a fairly complicated integration technique for us to for doing this type of problem. Another way is to just take the derivative of the answers and see which one matches up with it. So I'm pretty sure this is the answer here. So the derivative of x e to the x is e to the x. It's a product rule. So you take the derivative of the first x to keep the second, plus x e to the x minus, no, that is not it. Sorry about that. It's they used the wrong letters here. Okay. They got a capital. I guess that's not a capital X. It sure looks like it. All right, let's do it the other way, which is integration by parts. So it's u equals 6x, dv equals e to the x. So du is 6 dx and v is e to the x. So the integration by parts is uv minus integral v du. And that's 6x e to the x. So that gets rid of a couple of these answers, like just that one and that one and that one. Okay, we're in pretty good shape here. Minus integral e to the x, 6 dx. So that becomes minus 6 e to the x plus c. But we got rid of a bunch of them with that there.
Nice.
All right, use integration by parts to find the integral. So we'll just do it here. So your u is the natural log of 2x and your dv is the dx. So your v is the x. Your du, the derivative of this is 1 over 2x times the derivative of 2x, which is 2. So that's 1 over x. V equals this dx. So it's again uv minus the integral of v du. All right. So we've got x times natural log 2x. So that gets rid of that one. Minus integral v du x times 1 over x dx. So that becomes minus the integral of just dx, which is just minus x. So that gets you down to that second one there, plus c.
Okay.
All right, so we're on to let's see here, 35. Volume is solid.
Yes.
All right.
Mhm.
All right, very good. All right, so the curve here looks something like this roughly. And so we're revolving this area around the x-axis. So the integral is pi r squared. That's for a circle. And this, you're squaring the square root of 2x plus 9. And you're doing it from 1 to 5. So the nice thing is that square undoes the square root. So when you go to your calculator here, you leave the pi on the outside, but you're just integrating this 2x plus 9 dx, which you could even, I mean, you could even do by hand. The answer has a pi in it, so those are out.
Mhm.
And then so this, like, I'll actually do this by hand. So it's x squared plus 9x from 1 to 5 with a pi out in front. So that's 5 squared 25 plus 45 minus 1 squared plus 9. So that's 70. And then this is 10, so minus 10. So you get 60 pi as your final answer.
Okay.
All right, so let's look at the next one here. Oh, it took so long to load. There it is. Okay. The price per share. All right. So again, they're kind of giving you like some, like I would say so far, probably only been a couple of questions, but this is another one we didn't really see.
Mhm.
This is considered an average value integral. And I don't know how you would know that as like a first time calculus student, but
Yeah.
the average value is you need the limits of integration like this, and there's a formula 1 over b minus a, and then it's t 25 3t plus 25 dt. So the idea is you're averaging the result over a certain number of years to know like how much per year you should expect. And we kind of talked about this in the context of like investments, but it's not really a good ideal reference, especially with all the volatility that we've seen lately. But this is it. It's an average value integral 1 over b minus a from a to b f of x dx. All right. So back to the calculator. All right, so it looks like it's 61. And these have all been exact. Like I'm not like estimating or rounding. They're all just working out.
Okay.
It because I expect to see the answer that I expect to see one of the answers when we do these problems.
True.
So I'm not trying to, because you're not seeing, me typing it in, you're not seeing me using the calculator, but it does all work out.
Okay.
Okay, so this is a time value money continuous flow problem. So you integrate from the number of years 0 to 10, and it was 0.04x plus 900. That's like the amount that you're putting in each year. So you're putting in a little bit more each year, and then it was e to the minus 0.08x dx, like that. And then we just put this into a calculator. You have to, because it's numerical answers. They're not nice like we've seen in some other problems. But this is like you deciding, okay, I'm going to put in $900 a year, but I'm going to increase it by 4% each year, and I expect an 8% return on your money.
Mhm.
From 0 to 10. E caret. Okay. Okay. I just want to double check this calculation. I did get A, but I'm concerned. Yeah,
Okay.
because I couldn't remember if it was a negative or a positive, but so you're also taking account of the discounted value of money that your money's worth. I don't want to say that. It's like $100 10 years ago is worth more than $100 today,
Right.
kind of thing. Okay. 38. Does that seem right?
The next one, yes.
Okay. Oh, so these are even better. You don't even have to figure out what the value is. So the rule is, if you integrate from a to infinity 1 over x to the p, where p is greater than 1, this always converges. So this one is convergent.
Okay.
And that's just a known thing.
Rule.
Rule that it is kind of an interesting part of calculus 2, where you no longer look at things in terms of the numerical value. You actually start comparing and saying, okay, because this other thing converges, then this must also converge. And it's kind of and then you go the other way. Because this diverges, then this other thing must diverge. It's a different way of doing math. But this one diverges for the same reason that the other one converged, because it's x to the 1. And that just does not converge. We're already at the last one. Okay, good.
Yeah.
Good. Well, the last ones went really fast here, whereas it seemed like I was like, oh my gosh, 40 questions.
It was rough at the.
I was super concerned that because you had said, well, maybe you need 3 hours. I'm like, well, maybe you did. At the more, we'll call them the brand name universities, like your Harvards and your Stanford, the world, they do give final exams that truly take 3 hours to do.
Jeez.
Which is I mean, it's a long time to do anything, just sit there for 3 hours straight and not get up, not go to the bathroom, not want to just do something else. So for this last one here, I believe it converges. I would like to confirm that with the calculator, although I'm pretty sure it converges. I'd bet a good amount of money on that. So let me 24 e to the 5x. All right, so the nice thing is this actually equals 4.8, which we know converges. Nice thing is we don't have to check any of the answers for like whether it's a fraction or decimal. But we can certainly spend a little more time here if you want, either looking back at some of the problems or anything else here. But you tell me what you'd like to do.
I think I'm good, honestly.
Great.
Yeah.
All right, let me stop recording here. Yes.